many of the discoveries have happened. So that's how many of the discoveries have happened. Okay, so similarly, the magnetic discovery also happened. So, but the very first thing when we think about magnet, the very first thing that should come to our mind is that the magnet attracts to some metal. Okay, so which are those metals? They're
Sir,
they're
iron,
very
zinc, and cobalt.
yeah. Okay, yeah. So I think like Veer is right. So the magnet can attract to iron, nickel, and cobalt. Okay. So iron, nickel, and cobalt, we call them as the ferromagnetic
Magnetic
material. We call
material.
them as we call them as the
Ferromagnetic.
magnetic material because the magnet can attract. There is a reason why the magnet attracts that. Okay, I'll tell you why. Okay, the first thing is like so I have a small iron nail in my hand and see I'm going to like see, this is fine. It's basically sticking, but I'll slowly drag it, and you'll see that. So there's a gap between the magnet and the nail, but still it is getting attracted. You see that it's still in the air. It's still trying to attract. Okay. So now, any reason or anything you want to tell about this? Why, in spite of not being in contact with magnet, the iron is still in the air. Okay, you can see a good gap
Sir,
between the magnet and the
sir,
iron.
Because the magnetic field attract.
maybe because the magnet is near the poles and the poles are stronger for magnetic attraction.
Oh, okay, that's one answer. So somebody else also was
Sir, the
telling
magnetic
something.
field is stronger at the ends of it. Ends of the magnet.
Okay, Ojas is telling. Okay, yeah, you're right, Ojas. Actually, what happens is, children, magnet is such an amazing piece of material that magnet is the only material which has this energy spread all around it. Okay, okay, you we can just see this magnet like black in color, but what exactly happens is that so in the if the what we see physically is one thing, but its energy or its power is like spread all around the magnet. Okay, so that's the whole reason. In spite of like there's a in spite of having a gap between the nail and the magnet, the nail is still like getting attracted towards the magnet because the magnet spreads its energy like all around it. Okay, so, but if you ask me a question of how far this magnetic field can go, it can go to infinite distance. Okay, it can go to long distances. But only thing is, as I think Ojas rightly pointed out, that it's stronger near the poles. That's the whole reason. Whenever we are close to the pole, it's trying to attract. Away from the pole, it doesn't mean that there is no magnetic field. Magnetic field is there, but it is very weak. So the magnetic field of this magnet is traveling to infinite distances. But only thing is, as you go far away from the magnet, what happens? The magnetic strength reduces. Okay, that's the whole reason we don't feel it. But when we come close to the poles, it's very strong. Okay, we can feel it. Okay, uh, that's one thing. And the other thing is, I wanted to like know from you guys of like. What do you say? So why does the magnet attract? Where does the power come from? What is the actual reason why the magnet has this power to attract or have this capacity to attract? Can anybody tell me?
Or maybe it's because of the molecules or atoms of what magnet is made of.
Okay, that's one thing. Okay, carry on. Like somebody else wants to add.
Or maybe magnet is attractive. It attracts only some elements or particles. So
Mm,
the elements it attracts, maybe
mm,
there is some change in their atoms or molecules.
mm. Okay, fine. So what I'll do is I'll just turn my camera. Okay, guys. So I don't know if you would be able to see this. Okay, I'll write it like this. Sorry, there's no power at my place, so I thought I'll do it on my laptop. There's no power here, so that's the whole reason I'm doing it on my mobile, and I have to take this book to write. Okay, what happens, student? So you can take any material. Okay, so you have You can take any material. What happens internally? You have this the smallest particles, okay, which is atom. Okay, what happens? The atoms are basically in every material is made of atom, but what happens is that they all are looking in different directions. Okay, different directions, but only magnet is the only object or the material in which all these internal particles are facing or aligned the same direction. So that's what gives the power to the magnet to attract. Okay. So now let us assume that this the top one which I have written is iron. Okay, iron doesn't have the power to attract, but it can get influenced by the power of the magnet. Okay. Suppose now what happens is then there's, as we discussed, that there's a magnetic field around the magnet. Okay, suppose the iron is like this, but as soon as it comes under the influence of the magnetic field, what happens? Even even the particles inside the iron, they start looking in the same direction, or in the direction of the magnetic field. So that's how this happens even with nickel and cobalt as well. So that's the whole reason the magnet is able to attract only these three elements: iron, nickel, and cobalt, just because they have the property that they are getting easily influenced by the magnetic field, and they can change their orientation according to the magnetic field. Okay, these are only three material that.
Sir, you are on mute.
Okay, yeah. So that's the whole reason. Like we have that uh, the magnet gets that property of like attracting, and that's we also like just saw. So the reason why the magnet is able to attract only iron, nickel, and cobalt, just because iron, nickel, and cobalt have the property that they can get influenced by the magnetic field, and they can the internal particles can change their directions according to the magnetic field. Okay, so that's the whole reason they attract iron, nickel, and cobalt. Okay, so now let's
So if
start moving it. Okay, let's yeah.
sir, so if either of the materials are converted compounds, for like example, iron is converted to ferrous sulfide, it will lose its magnetic property.
Oh yeah, yes. So what we can do, what happens is, of course, with chemical reactions, okay. So we can make make any material to lose its original property. Yeah. Okay. So the original property gets lost, even with even if you like hardened, even if you harden the iron is suppose hardening in the sense you heat up the iron to a very high temperature and suddenly cool it. So then what happens is the internal particles of the iron become so rigid that it's no more an what magnetic material. Okay, so by various like methods, both physical as well as chemical methods, you can change the property of any material. So then the original property is lost. Okay, so now let's get on to understanding the poles of magnet. We were speaking about like having poles at both ends. Okay, sorry, having poles. Okay, and some of you Veer as well as like Ojas also said that. So if we make this to like either float in the water, make it to float in the water, or like just tie a string to this and allow it to just be in the air. Okay, so what happens is they'll turn and like point towards one direction. Okay, so that direction is nothing but the geographical poles. Okay, so even that happens. Okay, I'll just try. I have a thread in my hand. Okay, let me see. I have both. I also have a bowl here with water filled in it. So let's try with both of them. So I feel that like a water in a bowl is actually like a more easier way, because if you have a string and you want to tie it, so you have to tie the string exactly in the center. But I don't know, it becomes difficult to tie something exactly in the center. even a little bit of what difference here and there, so that makes it tilted. Okay, so
I tried
let me
to
see.
try the water method you told us to do, but then I used a
Yeah.
bar magnet in the water. I placed the bar magnet and the bar magnet seat.
Okay, then no, no. What happens is, so then you need to the container which you are using is also very important. So the container in which you are keep placing the magnet, so that needs to be bigger than. Okay, if that is bigger, and then it will not sort of like drown.
Okay.
Okay, so if the container you are using is big, so it will not drown.
Okay, sir.
Okay, just a minute. I'm taking a bottle cap. Okay, I'm just I'll pack this with like a lot of magnets so that they don't. But I'm not sure. Even this might also drown. I don't know. Oh, it's going in. So I need to take a bigger one now. Oh, I'm taking a smaller cap. I need to take a bigger cap. Just a minute. Oh. Any guess how many magnets I would have, children, with me? Like, any guess?
Maybe 15 to 20 magnets.
Okay, then any other guess?
Also 13 to 11.
It's not visible.
Sorry, I'm no. Am I visible?
Yes, sir.
Yes, sir.
Yeah. So how many magnets?
You
Any
are
guess?
visible, but you are
Sir, you may
doing
have
Sorry?
15 to 20 magnets, 15 to 20 ring magnets.
Okay. Oh, you're telling the magnets in my
experiment is not
hand.
visible.
Yeah, you're telling the magnets in my hand, but I'm trying to ask you the magnets that might have in my store. You know, I have close to over like 6,000 magnets with me. 6,000 ring magnets.
Sir, what do you do with those magnets, sir?
I play. Okay, yeah, fine, children. So I just set it up. See, you said that you tried it, but the important thing is here. Okay, so a cap like this. Okay, this cap it was actually drowning. Okay, so there is something called as the buoyancy law. Okay, so which will like sort of learn sometime later. See now, so that's the reason. If you take a bigger container, it will not drown. Or okay, see, I took a bigger container, it stays there. And see, I'm just turning. You see that the magnet actually comes back and settles in exactly in the same direction. Okay, so that direction is nothing but, as you guys rightly guessed it, there is a magnetic north. Sorry, the geographic north and the magnetic
Yes,
south.
sir.
So this is basically. See, suppose somebody give you a bar magnet, and at least on the magnet, if it is written north and south, so you can, even if you're lost, you can basically just make the magnet float in the water and find out like which direction you're going. But of course, during the day, what happens is that you have the sun. If you know where the sun rises and sets, you will be able to understand the north and south. But this is mostly used during the day, during the night. Okay, and during the night, especially when you're on the ocean and there is nothing else seen around you, and it's only water and water and water. Okay, that's where the mariner's compass was actually by the records. It was first discovered by the Chinese. Okay, so that's what is there in the records. But it has been also used by like discovered by like many other people across the world. But by the records, it's mentioned that the Chinese were the first to do what discover and what mariner compass using the magnets. Okay, this is like superbly fun. So what I do with this is, children, like not just this. Here, I see something is happening with that magnet. Here, I'm using a magnet outside it to spin this magnet. I'm spinning the magnet outside. And you can see that the magnet went in the. This is actually slow. I can spin it faster. Okay, so you just keep spinning and that will keep turning. Okay, so like there's a lot of fun like we can have with magnets. So this is about the poles. Okay, so now suppose somebody gives you a magnet and they ask you like what is the can you find out the north and south pole of this? There's a simple experiment. You just place a magnet in the allow the magnet to float in the water by placing it in a container, and whichever side is basically facing the geographic north, that becomes the north pole of the magnet because it is basically getting attracted to the magnetic magnetic south of the earth. Okay, so the side which is facing the north of the earth, geographic north of the earth, is the one which we can just mention it to be the north, and the opposite side of course would be the south. Okay, given any magnets, this simple experiment will basically help us to tell what do you say, help us to tell like which is north and south pole. Okay, see, actually I wanted to today actually sort of we are running short of time. Neha, is it that we have to end the class in half an hour?
Sir,
Hello,
I
sir.
have a doubt.
Just a minute, Veer. Neha, should we end the class in half an hour because you said the auto record might end or something like that, or 40 minutes? We have
Okay,
40 minutes time.
40 minutes.
Okay, so we'll go till 35 minutes. Okay,
Okay.
so by the
Okay, sir.
35 minutes, we can end it. Okay, yeah. Okay.
Yes. Yes.
Veer, yeah, you had a question where you can ask me.
Yes, sir, I have seen on YouTube that there is some liquid that if it comes into contact with the magnets, it reacts like some differently.
Yeah. So that we call it as a ferroliquid. Okay, we call it as a ferroliquid. They are also actually you also get magnet in the form of liquid these days. Okay, so it's just a magnetic particle that's mixed in and like very highly viscous or highly thick what oil.
Viscosity. It has lot of viscosity.
So high viscosity in the sense which is very sticky. Okay, so what happened? They put a lot of magnetic particle in and like very sticky liquid. So you'll get a feeling that there is a liquid magnet. Okay, even if you take iron close to that, you'll see that there's a sudden spike of magnetic material and all the stuff.
Yeah,
Okay,
the ferroliquid is also called as venom liquid sometimes.
I don't know.
Because near magnet it acts like it's alive, right? So many people think it's like that.
Okay. Yeah. So, and the best movie, children, like one of the, so just because like we asked this question, one of the amazing movie I watched, like which has some magnet. They use magnets to do something. They call it as a microbot in that movie. So the movie called as Big Hero 6. Okay, if you guys have watched that movie, that's amazing. They use some small microbots. Like the microbots are basically they're like magnetically charged. Okay,
Sir,
these microbots can like
the
sort
movie.
of they can
Big Hero
attach to each. Sorry.
Big Hero 6.
Yes, Big Hero 6. That's one of my favorite movies. You can see that all those microbots attach together and they can like perform different gigantic structures. Okay, yeah,
Yes,
that's like yeah. So that's an amazing movie to watch. Good. So, children, any other questions you have with respect to magnets? We can discuss because we have 5 minutes. Because what's happening is because we know that we are using Zoom from today, and for now to try out for next like 2-3 weeks, we'll be using the free version. So that that's putting us under the restrictions that we need to end the session like within like 40 minutes, not 40 minutes, to be safer, 35 minutes. Because we want to record this session. Okay, if it ends on its own, the recording goes off. Okay, this is again because we have switched the platform and we want to try all the features before we get into having a full version of like unlimited hours. Okay, so we have 5 minutes, so you can ask me questions. Yeah.
But it's actually not necessary that you'll need attend like for only 35 minutes or 40 minutes. Sir, if it's like the session is near to end, you can just leave the session and join it again. That will reset your time.
I got that point. Yeah. Okay, any question with respect to magnet? Please ask. And there's one more interesting thing which I wanted to do actually. In the next class, I'll show you like we'll build an what magnetic levitation setup. I have two setups. Okay, so with the help of we'll be doing it actually three. So one I have like the simplest thing is I call it as a magnetic car. Where we can build a car without then without touching the car, we can use a magnet to just basically propel it or push it, push and pull. And the second thing is I haven't like I call it as a magnetic fan. Okay, so where you just like keep it, and like if the air comes, it will be just keep rotating on its own. So, but it will stand with the with the power of magnets. And the third thing is magnetic levitation. Like I think this is a very popular thing you guys would have seen, but I'll teach you the basics of it and like how to build it. Okay, that's the important part. Okay, so we'll be doing magnetic levitation. So there are three experiments which I'm like sort of planning for next class. A very simple experiment. Even if you just have ring magnets and cardboard sheets, that is enough for you to like build it along with me. So for me, these sessions, now I don't want it to be like just I'm showing you something and you're like you're watching what I'm doing or you're listening what I'm saying. But I would be very happy in case we start building together. That's the reason we send the list of material which you can sort of, if you keep it ready, that like we can build them. Okay, if not anything, what you can do for the next class is you can have some ring magnets and some cardboard sheets. Cardboard is that carton box, the carton box boards you get, right? Even if you have that, that is fine. Okay, so we can build something
No,
together.
the cardboard sheets are provided in the PrayogPeti. I have it. So the cardboard
You
sheet.
have a you have a PrayogPeti, is it weird?
Yes, sir.
Or then you should have ring magnets and all in that. Which class are you in? Where?
Sir, sixth.
Oh, six is it? So then you would have magnets and all those stuff. So you can then, I mean, then I understand that you said that you tried something and it did not work. So now what you can do is you can use a bigger container to hold the magnets. Okay, then it will not drain. Okay, good.
So one question, how can I get this PrayogPeti?
So PrayogPeti, what you do is there is one Didi here. Her name is Neha. Okay, she's
Okay.
also in the group, in the PrayogPeti group you have, right? You can
Hello,
basically message
whoever wants
this
to
is
buy
Neha.
PrayogPeti, please personally message
Yes,
me.
myself. Okay, yeah. Thank you.
So there is one
And
Neha
what will be
Didi. She's also part of the
Doubt,
WhatsApp group,
sir.
so you can just message her. Okay.
Sir, I have a
okay.
doubt.
Yes, wait, please ask.
Yes, sir. Sir, so I have seen a lot of times that magnets, when kept close to magnets or like the same magnets and like some cages near fridge or near TVs or near hot things, it loses
Hmm.
its magnet property. It gets loose. The magnet gets weak. So how can we preserve the magnet so like it won't get loose?
See, the only way to like sort of, there are two ways that happens, Veer. One is suppose your magnet is stronger. Okay, so then it can also spoil the device. Generally, what they do is they warn that like suppose all the even I'm wearing this earphones, right? This has small magnets. Okay, generally people who have some old people, they have something called as a pacemaker in their heart. Okay, so if they have a pacemaker, what it does is it basically ensures that the heart rate is like
Hello,
maintained
sir.
properly. Okay. Yeah, yes, Neha, we are getting coming close
Sorry
to
for
it. Is it?
interruption. We have only 5 minutes
Yeah.
left, sir.
No, 5 minutes is fine. Yeah, well, I'm keeping
Okay.
track of it. Okay.
Sir,
Yeah.
I
So
have
what
a
happens
doubt.
is that wait, Siddhant, I'll finish this question answer and then you can ask. Okay. So the magnetic field might interfere with the pacemaker. They said that if you have a pacemaker, you should not have any magnetic thing on your body. Okay. That's one way that the magnet affecting a device. Okay. Suppose you have a neodymium magnet and all, which is very strong. If you take it near your digital clock, so that will damage your clock. Okay, so I had warned a few of my what the students, telling that please don't try it. One student, he was like he was overexcited. He wanted to see what happens. So he brought a neodymium magnet near his what electronic watch, and the watch it started showing like it started becoming slower and slower. Okay, so what it does is it corrupts the memory of the watch. So anywhere you have, especially you have hard disk or you have pen drive, you should not take it close to the strong magnets, because it can spoil the memory of it, damage the memory of it. Okay, to answer to Veer's question, if you want to preserve a magnet, best thing is you don't keep it close to any electronic devices, because electronic devices produce magnetic field. Okay, that magnetic field might affect the magnetic field of our magnet, and it will sort of see as I showed you. So the losing of power, in the sense, what happens, see, I showed you that all these things should be in the same direction. So losing of power, in the sense, some of these particles, they get disoriented and they start looking in different directions. So as they start looking in different direction, that means they're losing power. Okay, so you should not bring any other stronger magnets close to this magnet. So that ensures that the property of the magnet is preserved. Yes, Siddhant, we just have 3 minutes. Siddhant?
Yes, sir. Did a magnet use as the circuit to join the circuit?
Oh, of course, they use small button kind of magnets, which they use because magnet can conduct electricity. Okay, so because it can conduct electricity, sometimes what they do is they do something called a swapping circuits. Okay, there are some small plastic kind of modules in which there are some magnets using which they can basically snap it. You can like attach it and you can snap it. So you can basically do that. So you can use magnets for like making and breaking circuits, building
Okay,
circuits.
sir.
You can do that. Yes, yes.
Sir, I don't think magnets are malleable and ductile.
Okay, so like what do you mean by that?
Sir, malleable and ductile means malleable, you can make any metal into like thin sheets or like kind of aluminium foil, and ductile properties majorly used in copper because it is a very good conductor of electricity, so they make it into small rolls of
Okay.
wire.
Magnet we cannot do it like that, but until while manufacturing itself, if you can like try doing it. But magnet, because it's not flexible, the magnet as a material itself, it's not flexible, so like it's difficult to do all those things. Okay, but these days I'm telling you, they're coming up with magnetic sheets. I don't know, even I have some magnetic sheets with me, thin one, those on the fridge and all, you just put up some stickers and all, right? They have like magnetic sheets. Okay,
Yes, sir.
so I'll show you. I have some magnetic sheets. Wait. Okay, so basically, see, this is basically a protractor. So if I wanted to stick it on a metal board or a magnetic board, see, I have a magnetic sheet attached to this. So this I can just like attach it to the magnetic board like this. Okay, so here I am attaching it to the magnet here. So like this. So these are thin magnetic sheets. Okay, fine, children. So what we'll do is we'll break today, and next class, as I said, we'll build those three experiments. In case you have just the ring magnets and the cardboard, that's enough. Like we can build it together. Okay, fine, children. So see you then. See you in the next class. Okay,
Thanks, sir.
bye. So I think we are like very comfortable with the Zoom. So now we all are able to speak and see each other. So that's great. Okay, fine, Siddhant. Thank you. See you.